Are you ready, kids?
Aye, aye, Captain!
I can't hear you!
Aye, aye, Captain!
Oh! Who lives in a pineapple under the sea?
SpongeBob SquarePants!
Absorbent and yellow and porous is he.
SpongeBob SquarePants!
If nautical nonsense be something you wish,
SpongeBob SquarePants!
then drop on the deck and flop like a fish!
SpongeBob SquarePants!
Ready? SpongeBob SquarePants! SpongeBob SquarePants! SpongeBob SquarePants! SpongeBob SquarePants!
Alright, SpongeBob, today I'm gonna teach you about DNA replication. But Sandy, isn't that complicated? Yeah, if you're a Alright, so to start off, now hold up. Sit your hick-ass, cousin-loving ass down and explain to me what the hell is up with your voice. I mean, you sound nothing like Sandy. You sound like Jeff Foxworthy you don't even sound like Jeff Foxworthy trying to be George Bush. You sound like you sound like a 12-year-old trying to sound like Sandy. I mean, what is up with our lips? I mean, everybody knows that we're not saying any of this, alright? Look, we got a really small budget, and by small budget, I mean we have absolutely no money. I mean, we're doing this for absolutely for free. We don't got shit. Wouldn't we be better off just like having like static pictures of us and just having a voiceover? I mean, like really, I mean at least that wouldn't be like agonizing, like, you know, having a just voicing over like us from other episodes. Alright, fine. Now, DNA is made up of three things. A phosphate, a sugar, deoxyribose, and an entire nitrogenous base, either adenine, thymine, guanine, or cytosine. These nucleotides form a double-stranded structure known as DNA, which forms into a double helix. That's what a double helix looks like. Now, before DNA could be replicated, first this double helix has to quote-unquote unzip. That's where an enzyme called DNA helicase comes in. DNA helicase's only job is to unzip this double helix, basically breaking the hydrogen bonds that hold the nitrogenous bases together. Next, enzymes are added to the two now separate strands so that they don't twist around and come back together and stay separated. This is necessary for them to be replicated. The two ends where the double helix separates are known as replication forks. Next step, DNA polymerase glides along the now separated strands, adding complementary nucleotides, that means A to T and C to G, and then remains on the DNA until it has been copied completely. That means every single base from one strand has reached its complementary base. DNA polymerase is then signaled to detach. Now that the DNA polymerase is done, you're left with two identical strands of DNA, each with one new strand and one old strand. This is known as semi-conservative replication. Now there you have it, DNA replication. Now I know!